Okay, everybody, so now here we go into question 2. So what you need to do in SPSS for question 2, I'm going to follow through this process. And going back into SPSS, so question 2 is also going to be about, so here we're going to get into effect modification. So if you look at question 2, it's about, we've already tested for confounding question 1. Question 2 is effect modification. For effect modification, you need to split the file by income because we're all looking at income as our effect modifier. So what we need to do for that is you need to go into create rank cases. So if you've done this already, that's great. So that's where you select your household income. So go to your variable list and you're picking the categorical variable for household income, not the one with the ruler next to it. That has too many missing variables that need to be looked at more careful, or irrational or illogical numbers. So you have to decide whether an income of $1 million is a possible income or if it's a missing value. Here, the categorical variables are already reset, they're categorized, and you have the missing values have already been recalculated. So make sure that you've already set your missing values here before you do this process. So take a look at your data first. But I'm going to assume that you've already done this process. So here you've gone into ranked into quartiles, clicking on ranks and setting your ties against the low. So you're setting 1, 2, 3, 4 levels of quartiles. And when you click on paste here, it'll create the syntax, which I've already done. So I'm going to click on OK here. And what I'm going to get as a result of this is a variable called the rank value of H4EC1. And it's going to give me, so when I go into a split file to get my different results by that new variable, I go all the way to the end and I select the last variable that was created. Now it happens that I've just rerun this twice, so it created an additional variable that's identical to the one I already had. So if you already have it, it should look like this graphic percentile of group H4EC1. And then you're going to go ahead and click on OK. That's going to split your file. And then you're going to go back into the crosstabs that you just ran for your crude and adjusted odds ratio. Now, in my case, there was no confounding by this variable. So I'm going to take that layer off because I don't have confounders. I answered question 1, I don't have a confounder. If you answer that you do have a confounder, go ahead and leave that layer in there. And so here I'm going to click on OK. You can also paste it into the syntax. And I'm going to get my output here based on level 1, 2, 3, and 4. Now this is what I did last week too. Copy and paste this into your question for question 2. This first thing you have to look at in question 2 is you're going to paste the syntax for your income rank variable, and then you're going to split the file by 1, 2, 3, 4, and then based on looking at the beta coefficient, is there a progressive equal increase in the beta coefficient from 1 to 4? So this is a new question. This is the concept of, is there linearity in the logistic or linearity in risk? So how do you look at that? So here, write the logarithms of the estimate for 1, that's 2.428. And then there's 2.50. So that's an increase of 0.8. And then you go from 2.5, if there's an increase of 0.8, if it's linear, you would expect a 2.8, but it's not quite linear here. And then in the final level, it doesn't go up by another 0.8, it goes down again to 2.2 logarithms of the estimate. So if I go from 1 to 2 to 3 to 4, the increase at every level is not the same. So you go from 2.4 to 2.5, that would be a 0.8 or 0.9 increase. 2.5 to 2.54, that's hardly any increase. And then 2.257 goes down a little bit. So here you don't have linearity. In fact, you seem to have an increase and then a drop. So you have a pattern where you couldn't just simply enter 1, 2, 3, 4 as it is. You can't use this variable without making a yes-no dichotomous variable. So then the second thing is, where's the right split? In my case, that group 2.257, that high income group, seems to be the group that's really different from the next. So I'm going to say income level 4 compared to income level 1, 2, and 3, because that's where the biggest contrast is that I see here in these results. So this output here on my split file, the Mantel-Haenszel, where it shows the 1, 2, 3, 4, and it shows the odds ratio. So that first 11.3, 12.19, and then the natural logarithm to the estimate or the odds ratio right under it. That's what you need as your starting point. That's how you make your decisions. And then with that output in the MS Word file, you're going to do that calculation of going from the natural logarithm of level 1, level 2, level 3, level 4. What is the difference between 1 and 2? What is the difference between 2 and 3? What is the difference between 3 and 4? Are they the same? Is it going up in a linear way, or does it seem to go up and then down? So what is the incremental increase at each level? If it's not different at each level, explain. So say, well, there was a big jump in level 3 to level 4, like in my case, or in your case, it might be at level 1 to level 2. Then that fourth question is make a decision about your comparison group. So here I looked at my SPSS output and I said, from here, I'm going to make a decision that group 4 is my highest income group. So this is basically going back to things you will have started and maybe even finished last week. And here you just write it up and explain the decisions that you've made.